more than 70 international journal papers and presented his work in more than 100 international or national conferences in the area of semiconductor devices, VLSI circuits and microwave engineering. He is the coordinator of NIST TIFAC code in 3G or 4G communication technology, which was established with a funding of around 10 crore from DST, few industries and NIST. Sir is a senior member of IEEE, member of VLSI Society of India, lifetime member of ISTE and a fellow of IETE. He is the faculty advisor of NIST IEEE ED Students Chapter and the executive committee member of IEEE Bhubaneswar subsection. 10 students have been awarded PhD under the guidance of Dr. Ajaykumar Panda sir. He is a regular reviewer of more than 10 index journals including IEEE, IET and elsewhere. Sir has organized more than 30 conferences at NIST and other places. Sir is also the co-author of book named Physics of Semiconductor Devices. He has also successfully completed number of projects funded by TST, UGC, MHRD and MSME. His group has recently fabricated out a mixed signal IC using 180 nanometer technology and it is its first kind in Odisha. He has obtained Odisha Technocrat Award for 2015 and obtained University Foundation Research Award in the year 2019 from BPUT for best publication in between 2017 to June 2019. I once again welcome you sir and request you to start the presentation.
Yeah, good morning, madam. Subhangini, madam. Hello.
Hello. Good morning, sir. Yes.
Morning. It is audible, right?
Yes.
It is audible.
Sir, even our regional director, sir, is here only. Sir.
Oh, professor is there. So, good morning, sir.
Sir, screen is not shared.
Very good morning, sir. The screen is shared.
But sir, first I am telling, sir, good morning.
Very good morning, sir. Very good morning. Welcome, sir.
It is audible, right? It is audible, and now I will share the screen then.
Yes, sir.
Yeah.
Yes, please go ahead, sir. All the best.
Okay, we're getting.
Okay, sir. Okay. So, is it audible?
Audible, sir, audible.
Okay, okay. Then screen is totally visible.
Yes, visible, sir, visible.
Visible, sir. Audible.
One minute, huh? I want to make screen. The full screen has to be shown, right? So I want to see the pseudo actually.
Press F5, sir. Press F5.
F5.
F5. Functional key F5.
Okay. No, it is not. See, you're this part, this one is somehow.
You go to slideshow. Slideshow, sir. Slideshow.
Okay.
Slide.
Yeah, I got it now. You can see. So, yeah, it is visible right now.
Yes, sir. It's a full screen, sir.
Okay. So, yeah, that's fine actually. Thank you so much. And thanks to all the participants and good morning. Very good morning. My name is Dr. Ajit Panda, as it is told. Any times, I don't know, have you given the control to me, and in that case, can I do the unmute to any people, or actually it will be? Can do unmute, right? Anyway, so good morning to everybody. And here actually we'll be talking about the 5G, not only transceiver actually, the whole system basically we'll be talking it in first 1 hour. Anyone has any questions, I think it will be good if you can they ask it also and can stop me at any time also. I will request the organizers so that they can give the chance to anyone to speak and can ask any questions. So as all of you know, the 5G is becoming very important nowadays, and the government, the people, everybody are expecting that to get the 5G in communications technology. India do not have now the 5G, but it is expecting that within 2022 India will have the 5G. Industry like the BSNL is struggling to establish the 4G, and if you have seen it in the recent news and all, actually BSNL 4G upgradations was given to few Chinese company, and because for this current Galwan issue, that has been stopped. Therefore, the company like BSNL is still struggling to get into the 5G, 4G, but there are many companies who actually are planning to have the 5G in India, like Reliance and all that. Therefore, in this talk, basically, I will talk about the 5G, how actually the system will be, how it looks it, and how actually one can work on 5G. So in that, actually, I will try to cover all the areas like antenna, the baseband, the RF front end, and each area basically I will try to show actually the research can be done and how actually this can be lead into number of papers and all that also. So keeping that in mind, actually this I will be presenting. I will talk some of the time for the transceiver, which actually we want to design it, make it, fabricate it, and characterize it. And apart from that, actually other things also I will be talking in this lecture. So when we look for the 5G, unlike that of the 4G, 3G, so few of you guys may ask it. It was 2G, upgraded to 3G, upgraded to 4G, and upgraded to 5G. But it is not true actually. The 2G, 3G, and 4G is almost same. It is an upgradation. Whereas the 5G is basically dramatically change of the 5G, and 5G is different totally in terms of the speed, in terms of the power, in terms of the connected devices, in terms of end user. 2G, 3G, 4G, usually we talk and usually we look as if it is for communication purpose only. But when we look for the 5G, the use cases are huge actually. It is for critical control remote devices, interaction with human, that is for IoT. Massively using IoT, those people who are working on massive IoT, basically they will be using this 5G media. Most of the smart vehicles, transports and infrastructures will be using the 5G, and as usual, the broadband communications. So 5G is used in almost all the areas and in everywhere actually. So when you look for the evolution of mobile communications and how actually it is going, then we can think it, from 1980 basically it started. The first UK mobile phone comes into the 90s, but to India, 2G, GSM, almost it is around 2000. In our city, basically first time we got it, the mobile communications in 2001 with the 2G GSM, which actually operated 980 megahertz. From the 2G, it comes to the 3G, then spectrum auctions and all that is started it, and 3G continued till 2010. Then 3G to 4G basically within this time of 2010 to 2020, where actually the different things like HFPSA, 4G spectrum, then 4G, LTE and LTE are started it. And at the end of this 2020 around, basically the 5G has started it, and it is expecting that the 5G will be till 2030. In 4G, we usually operate in 2.3 gigahertz and 3.4 gigahertz. WLAN type of things which actually used, basically used it at 2.4 gigahertz as well as in 5.8 gigahertz. Now, when it comes for the 5G, which one actually will call it as the 5G and what kind of frequency and all that will be there? That actually, if we look at, it is basically for the millimeter wave, which actually 5G things basically started around 1 gigahertz to 300 gigahertz. The whole millimeter waves actually the 5G covers. So, what is the vision of the 5G? Coming back to the industry types actually, Qualcomm's, which actually is the baseband processors for the 5G communications in the world market, and its basically vision is 5G is not only for the enhanced mobile broadband, it is basically for the mission critical services as well as the mission Internet of Things type of things also, massive Internet of Things types also. It has the low cost, massive Internet things, high density, mission critical services, as I told you, all that will be used in 5G, and it has the enhanced mobile broadband. This is what actually the Qualcomm 5G vision, and the baseband or the SoC basically developing based on this actually. When we talk about this, there is a lot of change actually has happened in last 2 years, and in this last 2 years, if you look it and if you think it about, it is assumed that, and people get surprised also, those who are working on the, let's say, ADC. I will take an example of ADC. Those people who work on the processors, they usually think that the processor or the ADC, analog to digital converters, cannot work it in the gigahertz speed, means gigabytes per second size. Those guys are very good also. They say that because it cannot do it, therefore Intel has developed the 4 processors, 16 processor type of things. But actually, in small device, like, baseband, which actually used for IoT, which actually used for broadband communications types, they are actually, right now, the ADCs are available at 12 gigabyte per second type, which is actually a drastic change compared to that of the 2-3 years before that actually, where actually we are looking for things like ADC, DSC, which will operate at maximum at 1 gigahertz or 1 gigabyte per second type. But now it is available in 12 gigabyte per second types, and Qualcomm is using that kind of basically SoC, system on chip, and RF SoC basically are using it to design the baseband as well as the communication circuits. When we talk about the communication circuit, not only the mobile, there is one is the UT, user equipment, whereas the other sides, if you look at, we will look for the access point and we look for the base stations. In all these access point and base stations, basically Qualcomm's type of processors are using. Not only Qualcomm, I'm not telling only the Qualcomm's and not doing the marketing for that. The other company like ADI, NXP type of companies are also doing it for this broadband communication set 5G. So when we talk about the 5G, the beauty of this 5G is the unified 5G design for all spectrums, types of bands. As I told you, it goes from 1 gigahertz to 60 gigahertz, 94 gigahertz. And the beauty of this 5G is it has the licensed spectrum, it has the unlicensed spectrum, as well as it has the shared license spectrum. Unlike that of 2G, 3G, you cannot share your license spectrum, which you have purchased it. But in this case, because for the operators' benefit and all that, actually shared license is also available. Below 1 gigahertz, long range massive IoT, whereas 1 gigahertz to 6 gigahertz, it is wider bandwidth for enhanced mobile broadband and mission critical chapter. Whereas above 6 gigahertz, it is millimeter wave, extreme bandwidth, shorter range of extreme mobile broadbands and all that. So in terms of that, when we look at for the 5G again has divided into 2 parts. It is called as FR1 and FR2. FR1 basically cover 1 gigahertz to 6 gigahertz, which actually many operators and people who are working on communication type, they say that some 6 gigahertz. Whereas above 6 gigahertz actually, above 6 gigahertz it is called the FR2. FR2. This again called as the new radio, and basically they call it new radio. So new radio FR1 1 gigahertz to 6 gigahertz. Whereas above 6 gigahertz it is called as FR2. And FR2 basically used for millimeter waves and extreme bandwidths and all that who needing it. But you know, from this telephone companies in Korea and all that, actually they have gone to the FR2. Whereas you know, for countries like India, we are till now in FR1. There are few companies who actually are expecting and who actually have given their roadmap that within next 2 years this communication service will be at 28 gigahertz. 28 gigahertz. Whereas you know, in India we are planning to have it in sub 6 gigahertz till now. I will come to that also. So this is all of you know it, right? The VLF, LF and all that. So nothing to talk about that, the frequency bands. But as I told you, 1 gigahertz to above 1 gigahertz, basically we call it as the millimeter wave type. Many people call it from 3 gigahertz also, but in communications we can call it as the above 1 gigahertz. And as I told you, 1 gigahertz to 6 gigahertz will consider as FR1, and above that actually will consider it as FR2. So when you look for the frequency band and when you see the operations type, basically you see these are the companies who actually are operating at different frequency types. So if you look for 1 gigahertz below, around this 700 megahertz with a 60 megahertz bandwidth, 230 megahertz bandwidth like the country like USA had. Coming back to 3 gigahertz and 4 gigahertz and 5 gigahertz. In 5 gigahertz or sub 6 gigahertz, basically 5G is operating basically from 3.3 to 3.8, as well as from 3.2 to 8 to 4.2 gigahertz. Compared to that of the 4G and all that, the frequency band, which actually I showed it something like this type, instead of that in 5G, the frequency band defines is something different type. And it basically defined in terms of N43, N41, like that actually. And India and most of this Japanese type of country actually is planning to have the broadband communication in N78. N78 covers basically 3.3 to 3.8 gigahertz. And India has license band basically from 3.3 to 3.6 gigahertz for 5G. Different countries have different frequency bands, but India is planning to have from 3.3 to 3.6. Whereas most of the European countries and Japanese countries are looking for from 3.3 to 4.2 gigahertz actually. Within this actually, there are different bands, 3 bands it is there, N41, N43 and N78. N78 is from 3.3 to 3.8 gigahertz. These are most important, you know, when we try to design the frequency. Similarly, you know, in 24 to 28 gigahertz range, as I was telling it, two companies are looking for, the band is 27.5 to 28.35, 24.25 to 24.45, 24.75 to 25.75. Whereas in this sub 6 gigahertz, it will be 3.3 to 3.8. For that, you know, it has a broader or wider bandwidth actually, wider bandwidth. Therefore, design of circuit with that wider bandwidth is not that easy actually, not that easy, and it is very difficult. And how actually it is difficult, that we will show it in next few slides. As I told you, the focus basically in sub 6 gigahertz, 3.4 to 3.6 gigahertz, majority of the focus basically. Now they are moving it from 3.6 to 4.3 also. This is sub FR1 as I told you. Then again, the 5G non-radio millimeter wave is focusing from 24 gigahertz to 29.5 gigahertz. This is what actually is mainly for the broadband communications that people are focusing on. And above that, you know, millimeter wave, which actually are using it for radar type of communications. But I am not talking much on that actually. But mostly I am talking with these two basically. Okay. The spectrum allocations with time, basically if we look at the low bands, less than 1 gigahertz and all that actually starting from 2017 to 2022 type, mid-band basically from 1 gigahertz to 2.6 gigahertz, 3.5 to 6 gigahertz, and above that actually 24 gigahertz to 40 gigahertz. Most of the times basically people like me concentrate on this one actually, 3.5 to 6 gigahertz, and this basically is taking it in the market, and that is the next few years actually most of the communication systems will be from 3.5 to 6 gigahertz. Then, you know, it is basically how it is different, Then unlike that of the access point, which actually we use it, in 5G cases actually, base stations will be in home. So home base stations actually will get it. Now in 3G or 4G, our base stations is put on it somewhere in a tower at a very high height, and that actually cover 2-3 kilometers drive. Whereas in 5G cases, maybe that in a flat, for each block there will be a base stations, which actually cover 100 meters to 200 meters only. That is basically are called as small cells. So these base stations again now divided into number different parts. One is called as the small cells, micro cells, pico cells, and femto cells. This pico, femto, and all that combined together basically called as small cells, and another one is basically called as the macro cells. And small cells basically is taking most important nowadays in case of the communication systems to have the 5G type. And there are 100 people, there will be base stations. Now one base station in case of 3G, 4G covers more than 1,000, 2,000 or 20,000 people. Whereas 5G small cells, which actually talking about, will be small one and will cover 100 to 200 people, maximum 1,000 people. So that the noise, the radiations, all that can actually be minimized and can be placed easily. Therefore, that will be very safety also in terms of all that actually if we talk it. So the communication systems basically will have a paradigm change when actually it will be in 5G type of things. The most of the important things, those people who are actually trying to work on antenna area, antenna plays one of the major roles in case of the 5G. In case of the 5G, that usually in our mobiles and all that we have one or two antenna basically, which actually acts at the the receiver as well as the transmitter. Whereas in case of this actually, the people are planning for adaptive antenna area, highly beam form, a 10-degree beam form. Usually in 3G, 4G type of cases, we have the omnidirectional antenna. Omnidirectional means there will be the frequency, there will be the radiations in all the directions. But in this case, in case of 5G, it will be totally directional type. And to get that directional type, you need the number of antennas. And hence, the antenna will have some things, 32 cross 32 type or 64 cross 64 type, which actually will put on at the front of these mobiles. Then another one thing is happening here, that to make it highly beamed one, 10-degree beam, radiation beams type of things, basically to do it, the people are using some things called the adaptive antenna array. Adaptive antenna array means depending upon your movement, actually your antenna will move. Antenna is a passive device, antenna will not move. But what actually it will happen is, it will get the different phases so that the beam, which actually you are looking for, the signals which actually you are looking for, the signal will be directed towards your mobile. That are few important things, which is again doing a paradigm change in case of the 5G. That is called the adaptive beam steering. And this is one of the important area. A lot of papers actually are publishing, a lot of people are working on this, and industry like the Qualcomm, Samsung, all that actually looking for the people who actually have expertise in adaptive beam steering, adaptive antenna array. This adaptive antenna array, those who are working on needs the knowledge of the signal processing as well as the antenna designs. These kind of things are also playing the major roles. So those who actually were doing the antenna practically, and if you want to do this kind of antenna, then this kind of theory you must know it. Then the major problems basically happens in the blocking, because it will be the totally directional type. If you put it, let's say suppose as I said it, if we put our mobiles, something like this type, this will be the end block. Similarly, because it will cover a very small distance, and hence there is a probability of the blocking of that. And how to avoid that kind of things are the challenges in case of the 5G. These are few blockings I am showing you. The high base stations density and multi-base connectivity provides the diversity, how to take care of that, and set diversity, blockage, that again makes it the interference, how actually has to avoid it, and how actually these type of things will be taken care. That are the major issues and challenges in case of the 5G design. So in terms of technically, if we go, main problems with the 5G design is power issue. Power consumptions may be very high with that of the millimeter wave. Any base stations or any, let's say, mobile usage, or let's say, suppose, any communication circuits, all of you know that actually receiving side, basically, there will be the receiving antenna, there will be an LNA, then there will be an RF chain, depending upon what kind of your circuit you are designing. This RF chain maybe, it may need a band pass filter, it may need again a VGA, voltage gain amplifier, depending upon what kind of baseband you have. And after that, actually, there will be have an ADC, analog to digital converter. This ADC nowadays, it's coming with the baseband processing also, and that are calling it as the RFSoC. And in its earlier days, there was only one receiving path. But nowadays, actually, with this MIMO, there will be 4 receiving path, 4 channels basically that is calling, or 8 channels basically they are calling it. And usually, in 2.4 gigahertz type or in WLAN type, basically an LNA consumes a power of around 20 milliwatt. A RF chain, basically this RF chain usually consumes that power around 400 milliwatt type, and ADC consume power around 350 to 200 milliwatt type. So if you look at all that, actually it will consume around 500 milliwatt type of power at 2.4 gigahertz type. Whereas, when we look at that 1 gigahertz bandwidth, that is 60 gigahertz, the power consumed will be something 2 watt. For a receiver with 4 antennas, the power consumed by this front end at millimeter wave would be around 4 watt and around 2 watt. Whereas, in case of a 20 megahertz bandwidth with a 2.4 gigahertz, the power consumed will be 120 milliwatt. Therefore, those who actually are working on these RF circuits, those who are actually working on this PA, LNA, power amplifier, LNA type of things, the major challenges for them is how to reduce the power consumed. That becomes a major issue actually, and that has to be taken care. So this is the challenge, and this challenge you have to overcome it. Who? Basically the researchers, not that the industry guy. Industry guy does the content, combine everything and do the business, but it is actually the faculty who should do the research on this LNA, maybe that on the RF chain, what kind of VGA it should have been, what kind of band pass filter it should have been, what kind of ADC it should have been. And this basically called the front end architecture, front end side. This is called the baseband. Any access point you say, any baseband you say, it will have these 2 parts actually. One, the baseband processing, which actually mostly the computer science people do it. It has the different applications, whereas in the physical layer, basically this RF part. RF parts have ADC, RF chain, LNA on the receiving sides and antenna. And this is where actually most of us do the research, and most of us must take into account how actually the power can be reduced in these kind of things actually. This is the MIMO architecture, basically standard MIMO architecture I am saying. Therefore, this implication of power consumption, how actually we can able to reduce it, that has the problems actually. There are many ways through which actually this power can be reduced. Even the baseband, the people try to reduce the power. Basically, how that can be reduced? Reduce the resolutions to operate with bits. This is one important thing actually the baseband design must do. Non-negligible power consumption at baseband when running at gigasamples per second. But that actually they can do it and they can try it. Whereas, people like us, or electronics people, where I belong to, we adopt the hybrid architectures with many fewer RF chains than the antenna. So how actually this RF chain will be designed so that we can able to reduce the power and design low power analog processing network. How actually we design so that we can able to reduce the power. How the antenna will be designed so that at low power this antenna will operate. So each of these actually is one of the research areas for 5G, which actually we can take it and we can do it so that the power can reduce it. So is it available now? Yes. it is available. And how actually these 5G base stations the people are doing. 5G base stations. There are many ways actually the people are doing. This is a typical 4G base stations. Few companies, you know, what actually they are doing, companies like this Chinese companies like your Huawei and all that, what they are doing it, they are taking this 4G base stations and adding few components on that actually, adding few components. This 4G base station, as I told you on LNA side, this is a LNA, your RF mixers, your this dual RF voltage gain VGA, then the ADC. But as I told you, in 5G type of things, all this actually combining it into a module nowadays. This is in the individual discrete components, which were there in the 4G cases, right? Whereas, you know, in cases like this, there will be the RF SoC type of things where actually this will be combined together and is available in a IC type. Instead of doing that, the company like Huawei, what actually he's doing it, these modules he's taking it and adding some things like these types, envelope tracking type of things. Basically, he's using it and is developing his baseband structure. So what is this envelope tracking? This is another one research area where actually we can focus on power supply voltage to RF power amplifier is continuously adjusted to ensure that the amplifier is operating at peak efficiency for power required at each instant of the transition. That is the most important actually. And this envelope tracking is one of the main research area where many people are working, where actually few of us can actually focus it and can do it so that will help it in the 5G. We'll talk about this gallium nitride and e-gallium nitride technology for 5G, how it will come. So these type of things, you know, as I told you, 5 kind of companies already have their base stations where actually they have the multi-band radio unit, the bandwidth of 200 megahertz type, and high power of around 200 watt also. They have designed it, the base stations. Few other people what actually are doing it, instead of taking a 4G base stations and adding it, few of them actually what they are doing it, they are using it the FPGA solutions at the base stations. So these base stations what I told you, this one 4G base stations type, this type of things, and this one which I showed you actually, this baseband, they are designing it using the FPGA. Since FPGA field programmable gate arrays, that is there actually we can write the code and we can put it. Therefore, few companies what they are doing it, they are using this 5G for your cloud RAN and all that kind of things, L2, L3 design. They are using that, and front-end architecture actually they are developing. So Intel type of things actually they are using the Altera FPGA solutions to make the baseband. There are a few other companies actually who are using this Altera type of things also. I'll show you so that through the FPGA actually this part is designing, this whole part is designing, whereas you know RF front end is designing manually. These are few people, few companies who are actually doing the base station access point type of things using these type of things actually. We'll talk about this. And KVM, another one company basically have developed the base stations from the scratch actually. From the scratch it has developed it. Everything actually has developed it from the scratch. Design, fabrications, technology, everything has done it. And he has used the technology like that of Option Fusion M technology type thing actually has used it. And this is basically KVM base stations is telling. Therefore, these are few things, you know, based on that actually few people have got excited and they are trying to have their own base station. And few Indian companies are also now trying to have their own base stations actually, own base stations based on this Make in India, based on this, you know, Atmanirbhar slogan, which actually the government of India is giving it. Based on that, actually, few Indian companies are also planning to have their own base stations and expecting that before this December 2020, their base stations, Make in India type of base stations will come into the market. I don't know how far it will operate it, how far actually it will work it, but this is what actually few companies are also claiming it. So to do that, as I showed you, design, architecture, then the power. These things basically are the major concerns when actually we look for the 5G design. Therefore, it needs a architecture and technology trade-off. Architecture and technology trade-off, and that basically we have to do it. How actually our antenna interface will be, how actually what kind of materials we'll use it, what kind of data converters we'll use it, whether we will use the same CMOS kind of technology or not, all that actually based on that. Those who are working on this 5G, I'm not talking on this, the L1, L2 and L3 type of things, which actually mostly the computer science people deal with. I'm trying to cover the real physical design where actually these electronics, electrical people have the roles. So we need an architecture technology trade-off, and that actually has to be done. Therefore, this architecture technology trade-off can be given in any area. So any design, basically, when we talk it is called the abstract levels, which anyone has gone through this Pocknell type of book also, simple Pocknell type of books, they must have seen it, that there are different abstract levels of the circuit design or the system design. You start from systems, algorithm, architecture, RTL, gate, and transistors. And people like us, we cover from architecture to transistor, whereas algorithm, system, concept type of things, actually, we leave it for the people like the computer science lifestyles. So this basically gives the increasing behavioral abstractions, and this basically gives the increasing detailed realization of complexity. So anyone can choose, basically, someone may choose it on system, someone may choose in algorithm, but people like me basically concentrate mostly on transistor, gate, and architecture level. Recently, I am concentrating on this architecture level, but most of my areas, basically, I cover it on the transistors and gate level, actually, to design it, physical design, because that actually plays a major role. The power amplifier, when we talk about the transistors, the transistor consume the lot of power, and how actually the power we can able to reduce it so that the whole system can operate properly. So if you see it, if you see it, what actually I had given it, you see the power consumed by this band will be around 200 milliwatt, whereas power consumed on this one will be around 2 watt. Therefore, power consumed, as far as it concerns, it is basically the physical designer. Physical designers will have the major roles basically on the power combiners, and that we must have to take into care. So in that line, I would like to give some physical design, as I told you, transistor gate level. So I will cover some things on this transistor and gate level. Coming back to the basic physics or basic communication principles, which actually we teach to the students, there will be the data, digital data, let's say. There will be a transmitter. There will be an antenna through which actually the data will be transmitted, and it will go communicate. It will receive by a receiving antenna. There will be a receiver, digital signal, then the data out. Maybe that, it will again process and all that. But basic building blocks is this one. So when we do transmitter or receiver, what is the main area of a transmitter and receiver? In a transmitter, main block is the power amplifier. And in a receiver, the main block is the low noise amplifier. And both of that actually made up of using transistor. Therefore, when we look at some things like that of the LNA, or let's say PA, just I will take an example of a LNA. All these needs some MOS kind of devices. LNA or PA with the MOS kind of devices. Now, when we look for the MOS kind of devices, nowadays at 5G type of things, basically, can we use it? So when we look for that kind of things, actually, there is a, again, paradigm change in the MOS devices also. Starting from 19 nanometer, let's say in 2003 to, let's say in 2020, no more the CMOS kind of devices actually use it for this kind of purposes. And the people are planning to have some 30 devices, HEMT kind of devices actually. And in most of these, the power amplifier, which I showed it here, these power amplifiers are using the HEMT kind of devices. People try with the Doherty kind of amplifier, Doherty type of amplifier, but as I say, it needs the high power. Therefore, most of this transmitter, in case of the 5G, is using the HEMT kind of amplifier. Now, when we look for the HEMT, how actually we'll make the HEMT, that I will come. So basically what I'm saying that in case of the 5G type of things, when we go in, I'm trying to cover each area basically. And we go for the these type of things actually, the therapy devices are playing the major roles. Therefore, those people who actually are planning to work on devices basically, they will look for M kind of devices. So when we took M kind of devices, it comes to the materials also. It comes to the materials and it comes to the solid state electronic devices. So when we look for the solid state electronic devices, to make a M kind of devices, silicon, gallium arsenide, gallium nitride, silicon carbide, indium phosphide, silicon germanium type of things. But as I said, third-fifth compound semiconductor devices mostly used to make the solid state electronic devices, to use it at high power. So when we look for the high power, we look for the things like gallium nitride or silicon carbide. Each of these has its own importance and own merit and demerit. Therefore, most important here is the choosing of the proper materials. Therefore, those who actually are working on the device or circuits, basically they have to take and make sure that what kind of materials they are using it for their devices. This is another one big area where actually a lot of papers that people are publishing in the gallium nitride kind of materials, using the gallium nitride kind of materials. Or actually it will be chosen. It will be chosen in terms of the breakdown voltage, saturation velocity, mobility, each figure of merit. And this basically for any materials to choose, basically we choose it in terms of the Johnson's figure of merit. And this Johnson's figure of merit, if you look at actually, gallium nitride has the larger advantage compared to that of other kind of material. If we look at silicon goes it here actually, silicon 1, whereas the gallium nitride is something in this one. 1 by R on, let's say, the breakdown voltage, let's say the saturation velocity, let's say the electron mobility. Therefore, M kind of devices the people are preferring to work it using the gallium nitride kind of devices. In terms of the power and frequency, if we look at for the different semiconductors or the 5G kind of things, basically if we look at the gallium nitride M kind of devices, if we look at, you see, it is actually going up to around 100 gigahertz type of things. Whereas, leave it the gallium arsenide M kind of things, if we look at maximum power of 10 will be around 10 watt. 10 watt is 40 dBm. 10 watt is 40 dBm. If I am looking for, if I am looking for a base station whose output power should be 5 watt, that means if I am looking for a 37 dBm type of power at the output with a loss of around 4 dBm to 5 dBm, it will go to around 12 watt type of power amplifier I need to use it. Therefore, 12 watt of power amplifier, if I am looking for this gallium arsenide M kind of things, we will not able to choose it. Therefore, for the high frequency, for the high power, those who are actually looking for, basically people look for gallium nitride kind of devices, and here actually a lot of research work can be done it, and lot of research work actually the different people are doing. How actually you will take the value in terms of this gallium nitride material properties? It will have the wide band gap, high charge density, high electron mobility, temperature tolerance. In terms of HEMT, as I told you, if we look at it will give you the high voltage operation, high current density, high frequency, high impedance, and low capacitance. In terms of the RS systems, if I look at this gallium nitride HEMT, high efficiency, high power, smaller size, wider bandwidth, no doubt it will be the Rogers 1 and low noise. Therefore, using this gallium nitride HEMT kind of things for an RF systems to operate it at 5G, I can design anything actually, PA, LNA, switch, VCO, mixers, gain block, phase shifter, variable attenuators, all these kind of things actually I can able to do it by using this gallium nitride HEMT. Therefore, those people who are actually working on solid state devices, they can plan it for gallium nitride based solid state electronic devices based on HEMT kind of things, which actually will use for 5G. But we do it, device people, what we do it, we work only on the material, we work only on the device, but we did not think how actually it can be used in the circuit and how actually it can do it into the systems. Therefore, that our research areas, which actually we are doing it, slightly if we twist it, then actually we can contribute it for the 5G type of system also. So gallium nitride devices for RF applications, all these actually are there, using it in defense, LTE, everywhere actually, everywhere. And basically, here the challenge is gallium nitride do not have a substrate, its own substrate compared to that of silicon. Silicon has its silicon substrate, therefore silicon CMOS do not have any problem. But gallium nitride use either a silicon carbide as its substrate or silicon as its substrate. Therefore, gallium nitride on silicon or gallium nitride on silicon carbide is actually. So mostly these mobile handsets are at this type of things actually for in terms of the cost even when we look at basically we do it on the gallium nitride on silicon. But those who actually are working for defense kind of things actually they look for gallium nitride on silicon carbide. These are basically each of these actually are the research areas where actually the people can do the research and publish the papers. So is it looks something basically when we think it also only we think about the CMOS IC. But in fact, believe me, there are gallium nitride integrated circuits content. So what actually it is, this gallium nitride high power amplifier, your gallium nitride, this is your gallium arsenide of course, the gallium arsenide, your LNA, then limiter and all that actually using, and the circulator you need it for the isolation purposes. But as you know, when you go for the gallium nitride actually, instead of the circulator, we need the gallium nitride switch. Therefore, making a circulator as an IC is too difficult and not possible. And hence, this gallium arsenide type of thing, if we are choosing it, basically we choose it, in terms of discrete component. Whereas when we go for the gallium nitride, this switch, your high power amplifier, LNA, and this switch can be made it in the single IC. And this basically the gallium nitride tracer, gallium nitride take it. But my point is, there are gallium nitride content IC, and that actually belongs to the research area also. So most important. And hence, if we want to go for IC design, this is another one research area actually where we can focus. I will talk about that actually. 2 points actually. I will talk about this, how actually this will help it, and how actually what is its advantage compared to that of the SOC type of thing. I will come to that also. So gallium nitride HEM, all of you know it. Therefore, I don't have to talk on this one. Substrate buffer, 2DG, LGAN type of things actually using, and 28 GHz the base stations for gallium nitride IC is available. I will show you actually how we are working on this gallium nitride based front-end IC. This whole part actually, few of my research scholars are engaged basically to do this actually, to this whole part actually, and I will be talking on that, which actually will be using it for 5G. On that also, we have done few work. The challenges in this case, we go for gallium nitride IC, basically the thermal management, frequency and power, reliability, and
did to you all or to Rajesh?
hello, different kind of structures.
Ma'am, to upload, we should update timetable. So I should.
Hello. Any question?
इधर का साउंड दबाया, बाद में इसको लगा को वो साउंड चालू कर ये लगा दिया.
Hello. So go for this and based on that actually we have done a lot of research on this gallium nitride HEM type. One is the gate research GaN type, gate research silicon nitride with the HEM structure. So different kind of HEM structures actually we have done it, design it, and this basically we have fabricated it and characterized it actually. And this type of things actually we have seen it, how it will help the high power and high frequency operations and how it can be used it as the power amplifier communications technology. These are few of our own work actually. Each of that actually is published it, and we are actually giving it for the industry also. So this is the nice area I told. Now coming to the circuit areas. As I told you, we have to make it the IC, front-end IC. So to make it front-end IC, the gallium nitride on silicon fabrication companies. If you look at, these are few companies which actually are fabricating. So most of the research institute, most of our colleges basically we use the cadence kind of tools actually. cadence kind of tools which you use it to design the CMOS. But as I told you, gallium nitride based IC will be totally different than that of the silicon based IC. In case of the CMOS based IC, you get the technology file, model file from company like MOSIS or TSMC type of thing. But gallium nitride, the model file, the technology file is totally different. Its fabrication process is totally different, and hence there are few companies who nowadays have come up to help to the industry as well as to the academic and institutions. So MOSIS is one company who actually gives the model file and technology file first CMOS to the academic institutions or the academic institutions, whereas the company like Queen's you buy the model file as well as the technology file for the gallium nitride based IC design. I cannot use the tools like the cadence for gallium nitride based IC design. Most of you guys might have heard it, one tool called Microwave Office, which actually now acquired by the Cadence, and it is calling it the Cadence AWR. Cadence AWR type of tools basically are very good to use the gallium nitride based IC. And this, as I told you, this WIN Semiconductor is of giving the model file and technology file to academic institutions. Those who actually are interested, basically, they can connect with this fellow who actually is their sales and marketing guy for the WIN Semiconductor. People like me have signed an MOU with this WIN Semiconductor to get the gallium nitride IC technology model file as well as the technology file, and we are using the Cadence AWR to have the gallium nitride front-end IC. That actually another one research area where few of my research scholars are working, and few of you who actually are interested in So as I told you, our approach basically is of two types. One, design the whole front-end IC using from the scratch, design the IC, make IC, and after that actually you would go for the circuit. The other approach is purchase the IC, design the circuit, and see can it use it as an amplifier or not. So two approaches basically we have, and one of the approaches is basically design a transceiver circuit using MIMIC, where actually we can do the design, simulate, fabricate, PCB, purchase appropriate IC, and instantiate it through all the components. This is first approach, which actually can be done in 1 or 2 years basically by an MTech students also, to an existing one, if you are not doing a research one. And this is what actually gives a lot of benefit. The second approach, as I told you, make the IC by yourself, get the gallium nitride based PDK and design the IC and make the circuit by yourself. These two approaches basically we are doing it, and I will talk about these two approaches, but here I will stop it so that I will have another one lecture actually. There I will talk about these two approaches and how actually in the academic level, in the institutional level actually we can design, fabricate and characterize it actually. And for that, maybe that it needs the collaboration. So that kind of things actually I will talk it in my second half. But in the meantime, if anyone has a question for next 5 minutes actually, if anyone has the questions or discussions or any suggestions, that actually we should continue with it. Is it okay?
Which are the major funding agencies in 5G communications at this point of time?
Good, sir. Good. See, now in 5G communications, I am telling you, this SERB, Science and Engineering Research Board, DST. See, no doubt, the ISRO has a lot of funds because they are working for the 28 gigahertz. ISRO, DRDO,
Okay.
Space Research Organization, DRDO, Research Development Organization. These are actually putting a lot of money for the 5G kind of things. But recently actually, DST where actually most of our people get it, right? Most of the academic institutions. DST has a unit called as the SERB. Science and Engineering Research Board. On that, actually, recently it had advertised, for a disruptive technology. Disruptive technology, where actually not an existing research work which actually you are doing it.
Is there any postdoctoral funding projects are available in this area?
In this area, sir, postdoctoral, you see, there is a stream called NPDF, right? NPDF, National Postdoctoral Fellow. If you look it in India itself, there is one scheme called the FPGA, National Postdoctoral Fellow. There actually, anyone has a PhD, he can apply it. He will get some 60,000, and he can do his work for 2-3 years. I have two guys like that, sir. I have two guys. One is Narayana South, the other one is the Sangita Palo. So they are working on this area actually. Similarly, those who are doing PhD. So if there are faculty, you can guide few research scholars from their own pocket money type. For the women, actually there is one scheme called WASA, WOSA, Women Scientist Scheme. So that actually they can get directly around 40,000 per month type, so that for this type of things actually you can use. And in SERB, that disruptive management type of program is there, where actually the paradigm change type things will be taken and research funding will be given around 1 crore actually. There actually
this is open for all the research scholars, or else is limited to only for one who has done his research PhD. How this they will guide, sir? This SARB people, how they will select?
As I told, Government of India has different schemes actually. For example, as I told, for PhD actually, for PhD there are funding. There are funding. For postdoctorate also there are funding. Or the faculty to do the research also there are funding. Like that, this WASA scheme, one I told you, WASA scheme, what I told you, that no faculty need money. The students can get his own money directly actually from the DST, and he can do the research together with the faculty.
Okay.
In all these cases, he needs a faculty mentor.
Right. Thank you, sir. Thank you.
Any other questions or anything? Or Shubhangini, madam? Madam is there?
No, sir. Shubhangi ma'am is not here. So we'll wind up, sir.
So any other questions, or we'll stop it here, or what actually?
We'll stop it here, sir.
Sir, one more question, sir, from me. Hello. Hello.
Yes, sir.
Hello. Sir, it's we are seeing the bandwidths up to 3.6 gigahertz in India. Like, does this bandwidth is helpful for the upcoming network providers, or else this bandwidth has to be increased according to you?
No. As I told you, different actually frequency band. It is not bandwidth actually. It is the frequency band.
Yes.
Bandwidth, let's say 5G type of thing, bandwidth will be maximum 100 to 200 megahertz only. Bandwidth cannot be some 500 megahertz. It is given a frequency band where actually you can use a 100 or 200 megahertz bandwidth. So for different countries, different frequency band has been given. It is actually decided by International Radio Trade Union. So you cannot decide it. For India, right now, it is defined from 3.3 to 3.8. In future, maybe that India will look for more, and India government will get it more. That depending upon. But right now, actually, for India, it is assigned 3.3 to 3.8.
Right. Thank you, sir. Thank you.
For country like Taiwan, they have taken a 28 gigahertz bandwidth.
And any fluctuations like the user like country like Taiwan as an example you said, but does it make any sense in the speed?
Does it make any sense in the
in the speed or else network fluctuations or else
naturally, when you operate at when you operate at high frequency, naturally your noise will be less. Naturally your power consumption will be more, no doubt on that. But you have to take care of that. But noise, your disruptions and all that will be minimum naturally.
Okay. But the country like India, like for implementing 4G itself, we have invested a lot of money from the central government budget. As we have seen, there is a huge investment in the 2G spectrum, and some scam has been happened. Like as this is going to continue, like does the government require any huge amount of funding for the future implementations of 5G across India?
See, sir, that kind of things, I cannot comment it, and I don't know it actually. But
okay.
Irrespective of that, actually, I think we'll have the 5G in India also. Maybe that it will take some time. So it is good, for people like us to start working from now. Actually, people like us to start working from now, so that we'll be the front researchers in 5G area. That only I can say. But what kind of scam happened?
Most of the other countries like USA, UK, they are using now 7G, and their broadband speed is a little bit higher compared to India. But as a developing country like India, like 5G, like as I asked the previous question, I think like the investment for the government will be a little bit higher compared to other technologies, I think so.
I think that are different issues, There are different issues in terms of the money, in terms of cost and all that, and in terms of the philosophy and principle, So I will go to that, sir. Let us concentrate on technology so that,
Right, sir. Thank you.
Let us do some good on technology. Let us do some research so that, we will indirectly contribute to the society. That only we can say. So that the rest actually, let us leave it to the politics or those who make the rules and all that. For people like us, the teachers, let's concentrate whether we will do it on gallium nitride HAM, whether we will do an RF architecture, whether we will do FPGA, whether we will do an LNA, which indirectly will contribute. That basically should be our philosophy. That is my personal opinion, sir.
Right, sir. Right. Thank you.
Sir. Hello.
Yeah.
Sir, I had a question.
Yes.
Sir, you spoke about blockage. How we can overcome in 5G? You say that we anticipate blockage. How is it to be avoided?
Yes, that's what I told you. There will be a lot of blockage because it will be for a short distance actually. This 5G small cell, what I told you, it will be for the small cells. Therefore, how to take care of that blockage? We have to basically, we have to take into account of that kind of things also. And hence, one slide actually, I think I have. Means how actually we will put the base station. So let's say suppose what we can do is suppose there are two blocks. I don't have right.
Yes, sir.
The two blocks, let's say suppose we have in an apartment. Since it will be the directional one, therefore let us put in the wall of the other block so that it will direct only to particular block. When it is small one, just you can put it in the wall. Therefore, like that actually we can place it so that the blockage can be avoided actually.
Okay, sir. Thank you.
Because it is not for long distance actually. It usually used for small distance.
Yes, sir.
Hello, sir. Shubhangi ma'am is here with us, sir.
Hello, sir.
Yeah. Yes, madam.
Yeah, sir. It's very good session, sir. Actually, you are having the ocean of knowledge, sir. That I think VTU is lucky to have you, sir, as a resource person. So, Thank you, sir. And next session we
Some
will
other
start at
things we'll
12,
talk
sir.
Sure. The next session basically, how actually we have designed, how actually we have fabricated, and how actually we have characterized in a institution. That we will talk it. This, I talk it in terms of the industry prospects and all that. But I am from a small institute, not a big institute actually. In this small institute, how actually we have done it and practically we have demonstrated. That actually I will talk it in the next half. Okay?
Okay, sir. Okay. Thank you.
Okay then, madam. Thank you. Thank you so
sir.
much.
Thank
Thank
you,
you.
sir.
We'll meet at 12. Thank you.